Okay, students, so let's talk about proportions. I know. I'm excited too. Okay, so our objective today is I will use ratios to set up proportions. Now think about it. What does proportion look like? What does proportion sound like? Portion of a pie, maybe?
Maybe.
A piece of pie? Cheesecake is my favorite, by the way.
I like chocolate chip cookies.
Whatever. Cheesecake all the way. Anyway, so, well, part of a proportion is a ratio. And you already know what a ratio is. A ratio compares two quantities with the same attribute.
What does that mean, Ms. Gomez?
That just means the same thing. They're the same kind of things, like boys and girls. They're both people, right? Okay. So let's do a quick practice on what ratios are. So we're gonna draw some triangles, and then we're gonna draw some circles, and then yeah, we're gonna draw some squares. Okay, so let's write, what is the ratio of triangles to circles? Ms. Garcia, can you tell me that? What is the ratio of triangles to circles?
Let's see here. We've got 1, 2, 3. We've got 3 triangles, so that's our numerator, right?
Correct.
And our denominator is the number of circles that we have. 1, 2, 3, 4. So we've got 4 circles. Our ratio is 3 triangles to 4 circles.
Can you reduce?
Well, 3 and 4 don't have any common denominators, so I don't think so.
Why is this one not working? Sorry, kids. Yes, good job, Mr. Garcia. Good job.
Delayed reaction, but all right.
Hey, the phone. This is the phone's fault. So let's do another one. Let's do squares to total. Is this going to be a multi-step? Think about it. Do you already know the total, or is that something you got to do? Oh, it's something you got to do. Okay, very good. Okay, so let's find the total. What is the total?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 10 shapes total.
Fabulous. How many squares?
1, 2, 3.
And can we reduce?
I don't know. Can we? Do 3 and 10 have any common denominators?
Common factors?
Common factors? It's been a long day, Ms. Gomez.
Teachers make mistakes. Life happens. And moving on. They're all the same. Not the same, but you know what I mean. All right, moving on. And let's do squares and triangles to total. Did we do something similar to this with M&Ms or chips?
We did.
We did. Do you remember what we did?
I don't.
I think.
What was it?
I think we added.
Oh yeah, I think so. Because we have these and these. So we've got 3 squares and 3 triangles. So together that's 6. And we already have our total from before. So we've got 10 total. Am I done? I think I'm done, right, Ms. Gomez? We're done.
Guess what you forgot? Kids, can you tell her what she forgot? Ms. Garcia, you kind of forgot to reduce.
Oh, man. Okay. Well, I know that 6 and 10 are even, so that must mean that they can be divided by 2.
That's a fabulous place to start.
Okay, divide by 2, divide by 2.
Because if I do it to the bottom,
we do it to the top.
nice. And Done. Moving on, moving on. So those are all ratios. So let's talk about equivalent ratios. So, you know, the root part or the main part of equivalent ratios is equal. That means they equal. They're the same, but not the same. You know what I mean?
Yeah.
Okay, all right. So let's look at this ratio we created for triangles and circles.
Oh wait, we gotta define it. I don't know what that is.
Oh, I thought I said that. Okay, apparently I didn't.
Well, we learned it in class, but some of these kids, you know.
Okay, all right. So, numerator, denominator. Numerator, denominator. Okay, same value, but they look different.
Let's do an example.
Okay, so let's look at our first one, the triangles and circles, 3 to 4. Miss Garcia, okay, don't have a cow. We can do this, okay? It's okay. It's okay. All right? So we're just going to make it, they're going to look the same as if we drew the picture and whatnot, okay?
But they're still equal, right?
Right, they're equal. Okay.
So I can do this.
So let's say we had 8 circles. How would we figure out, how could we create that? How could we make it equal?
Well.
Okay, continue. Sorry, I didn't want to interrupt.
Okay. Well, I know that I changed 4 to 8, and I did that by multiplying times 2. And if I do it to the bottom, I gotta do it to the top. 3 times 2 is 6. So is that right?
That is right, because if I reduce this, guess what I get? That. And if I drew a picture and I I did a circle and I cut it into 4, this is my cheesecake. Okay, and I ate 3 of them and I only left 1 for you. I know. And then I did another piece of cheesecake and then I cut it into 8. And then I ate 6. I know. I love cheesecake. See? They're equal.
They're the same.
Fabulous.
Awesome.
Fabulous. Moving on. So let's talk about a little bit about proportions.
Okay.
Proportions. Let's talk about the definition.
Okay.
Proportions is an equation that has 2 equivalent ratios. My kids are so going to appreciate your handwriting. They're
awesome.
Laughing at my handwriting today.
Miss Gomez has nice handwriting. I like it.
So, what do you notice so far? What should the kids notice by now? A proportion is an equation that has 2 equal ratios. Equivalent ratios.
Right.
And we know what equivalent ratios are. And an equation has an equal sign, right?
Yeah. Kind of like that.
Yeah, a little bit. So, do you think that this thing that we did over here, could that be a proportion?
Well, it checks out. It's an equation. It's got an equal sign, and it's got 2 equivalent ratios. So did we already teach them that?
Hot dang! We know proportions.
Getting crazy over here. Okay.
All right.
We know proportions,
So,
aka equivalent ratios.
AKA, we've got this. Okay, moving on. Okay, let's do a word problem.
Whoops. Okay, ready?
Ready.
David, let's see, who's a famous soccer player? David Beckham.
Ay caliente.
This may not be so caliente. Scored 7 goals
Ooh, estinque.
out of 21 attempts. So he tried 21 times.
It must have been a bad game.
All right, let's find out how many times would he have to try. So how many attempts would it take to make, how many do you think we want him to make?
Heck, let's just try 14.
All right, let's see how many attempts he would need to make 14 goals.
Miss Gomez was the English teacher. So first we need to look at our important information, right?
Mm-hmm.
So we got 7 goals. We had 21 attempts. How many attempts would it take to make 14 goals? So the first thing we need to do is write our first ratio, don't you think?
Yeah, I think so.
Okay.
Because we know some information.
All right. I dig it. So we got 7 goals out of 21 attempts. Now, remember, it's a proportion. It has an equal sign. And we want to go ahead and start our other ratio. Now, labels are important. Labels are important. Labels are important. And if we've got goals on the top, well, what do we have on the other side?
Goals on top.
And if we had attempts on the bottom on here, where do they go on the other side?
Attempts on the bottom.
Man, I just made my life easier. Let's look at the rest of the stuff. It says, how many attempts would it take to make 14 goals? So I got other information I can put in now. I got 14 goals. And then my question tells me to put my variable under the attempts. Because remember that variable represents an unknown number. I don't know this number. They want me to figure it out. So if you feel comfortable working this out, you can work it out. And if not, we'll do it in class. Or we'll go over it in class.
Sounds good. Yeah.
And go!